That is nothing but JK flip-flop. JK flip-flop has got 4 combination of input allowed, that is j equal to 0, k is equal to 0, or either of them being 1 or both of them being 1. Whereas in SR flip-flop, both the inputs being 1 was illegal. Here, SR flip-flop is modified as a JK flip-flop wherein both J and K can be made 1, wherein the output can toggle. Have selected one of the possible circuit for JK flip-flop where there are 2 AND gates at the input and 2 NOR gates at the output. Let us try to analyze the first combinations of the input, that is J0 and K0, in which case output will retain the previous state. As you can see, Q and Q bar having a previous state of 0 and 1. So Q is fed back to top AND gate, Q bar is fed back to the bottom AND gate. However, both K and J are 0 on the application of clock. In any case, AND gate will have both the outputs as zeros. Now, 1 is fed back to the top NOR gate. So 0 with 1, NOR gate produces 0 as the output. Whereas in the bottom, 0 is fed back to the bottom NOR gate. 0 is coming as the output from the AND gate to the input of NOR gate. So 0 with 0 will yield 1. That means to say both Q and Q bar has retained its previous outputs. Now let us suppose the previous output must have been Q is equal to 1 and Q is equal to 0. Once again, K is equal to 0, J is equal to 0. Whatever is the feedback to the first stage, outputs of both the AND gate, however, will be 0. So 1 is fed back to the bottom NOR gate. 1 with 0 is 0. Here again 0 is fed back to the top NOR gate. 0 with 0 is 1. That means both Q is equal to 1 and Q bar is equal to 0 have retained the previous state. Let us go to the next state. That is J is equal to 1, K is equal to 0. That means J is equal to 1, K is equal to 0 means output should be set. Its complement should be naturally the 0. Now 1 is fed back to the first AND gate. However, K is 0, output of AND gate at the top is 0. Now 0 is fed back to the bottom AND gate. Even if J is equal to 1, the output of AND gate is 0. Now Q should be 1 here because J is being taken as 1. So let us see whether would it tally. So if this is 1, this is 0. So 0 is fed back to the top NOR gate. 0 is coming from the top AND gate. 0 with 0 NOR gate yields Q is equal to 1. Likewise, this 1 is fed back to the NOR gate here and 0 is coming from the AND gate. 0 with 1 NOR gate will produce a 0. That means when J is equal to 1, K is equal to 0, the Q will be 1. Let us take up the other possibility. That is J is equal to 0 in this case, K is equal to 1 in this case. Now we expect Q should be the 0. Now 0 is fed back to the top AND gate. So output of the AND gate is 0. Even any one of the input is 0, output of an AND gate will be always 0. Now 1 is fed back here, but J is already 0. So however, AND gate will have an output of 0. Now this is supposed to be 1, Q should be supposed to be 0 there. So Q which is Q bar which is 1 is applied to the top NOR gate. 0 with 1 has yielded Q is equal to 0. 0 is fed back to the bottom NOR gate. 0 with 0 has yielded Q bar being 1. That means whenever J is equal to 0, the output Q is equal to 0. You should also observe here K is mentioned at the top, J is mentioned at the bottom. Let us take up the last state in the truth table. This is more interesting. Here you are going to observe the toggle, that is J is equal to K is equal to both being 1, if Q is equal to 0, it will change to 1. If Q bar is equal to 1, it should change to 0. Now let us see. So because Q is equal to 0, it is fed back here. However, K is equal to 1 with 0, AND gate will produce 0. Here 1 is the Q bar, let us say previously. 1 is fed back to the AND gate. So all the 3 inputs, including clock. Clock should have been shown here. Clock is not shown. So this shorted to be applied to the clock. So 3 inputs are 1. So 1 is at the output of AND gate. Now 0, and this will be 0 because 1 has to toggle to 0. So that means to say to the top NOR gate, 0 is applied as the feedback. So 0 with 0 in the NOR gate will produce 1. That means 0 has toggled to 1. Now 1 that is fed back to the NOR gate at the bottom, 1 is coming from the AND gate, 1 is coming from the toggle state. So 1 with 1 NOR gate produce 0. So 1 has toggled to 0, 0 has toggled to 1 when J is equal to and K is equal to 1. So let us see this way. Yes, here Q is equal to 1. So Q is applied to the feedback of the AND gate. Because K is equal to 1, clock is applied and feedback is 1, AND gate is however 1. Okay, then it should toggle to 0, this should toggle to 1. So that means 1 will be applied to the NOR gate here. 1 is coming from the AND gate, 1 should be the toggle position. So 1 with 1 NOR gate produces 0. That means 1 to 0 toggling has happened. This 0 is applied to the bottom NOR gate. 0 is coming from the bottom AND gate. 0 with 0 yields 1. That means 0 should have been toggled to 1. So that is what we understand. When both J and K are 1 and clock is applied, then the outputs are going to be observed as toggling condition, where every clock will produce a single toggle. If there are more than one toggle on the application of one leading edge, then that is called as the race around condition. In order to avoid race around condition, we go for the master slave JK flip-flop. That means we are going to have 2 JK flip-flops forming the master slave. So J is equal to K is equal to both being 1 will produce the toggle as explained here. If J and K are shorted through an buffer, if it is shorted through a buffer, then JK flip-flop is converted as T flip-flop. If J and K are shorted through an inverter, then JK flip-flop can be used as a D flip-flop or data or delay flip-flop. So JK flip-flop can be converted as T flip-flop or D flip-flop also. So thank you so much.